Okay, composition of functions. Now this is the first definition that's a little bit weird. I guess maybe the other ones felt a little bit weird to you, but like those were basic algebra things. We were either adding, multiplying, or dividing. And how a composition of functions work is what you do is you take one of the functions and plug it into the other function, and you plug that entire function in. And so these are the two ways they can kind of be written. The left side, people kind of remember it as fog. That's fine if you want to. Or the right side, and this is actually the more classic example that I'm used to, is you write f of g of x. And really the right side is a good way to illustrate the fact that you're taking all of g of x and you're plugging it in to your function f of whatever you have. So to see it in practice, I have my two functions. F of x is equal to 3x plus 1. G of x is equal to x squared minus 4. I want to find fog, if you will, or f of g of x. So what I'm going to do is I'm going to take g of x, I'm going to plug it into f of x. So my g of x is x squared minus 4. My x squared minus 4 replaces the x on my f of x, and that gives me my brand new function. So instead of having 3x plus 1, it's 3, whatever g of x is, plus 1. And then I just simplify from there. Distribute the 3 to both terms. Negative 12 plus 1 gets me negative 11. And so f of g of x is 3x squared minus 11. Now here's the other way to kind of represent it. G of f of x, this is what I'm more used to. Honestly, if I'm going to write comments or help you with things or we're in office hours, this is the notation I'm going to use, but either way is fine. This could also be represented as, I guess, goff. You're flipping your g and your f. So for this, we're going to do a very similar process. We're going to now take my function f of x, and I'm going to plug it into my g of x. Maybe try to visualize that for a second. I'm going to plug 3x plus 1 into x squared minus 4. So that would look exactly like this. And now I have to simplify. And the simplification is a little bit of work in this case because I'm having to FOIL 3x plus 1, but it's not too terrible. So 3x plus 1 squared gets me 9x squared plus 6x plus 1. And then I still have to subtract that 4. And then I just simplify. 1 minus 4 gets me negative 3, and that's my answer. Now for a question like this, I have two options. I can plug in 1 into my resulting function that I found in A. So if you've already found f of g of x, or it's easy to find f of g of x, it's a perfectly fine route. In fact, you can check what we're about to do using that. Or my second option, and this is the route I'm going to take, is I find my g of 1, and then once I find that result, I plug it into my f function. So for starters, finding g of 1, I just plug 1 into my g of x function. 1 squared is 1 minus 4 gets me negative 3. Now I take that negative 3 and I plug it into f of x. So f of negative 3 is equal to 3 times negative 3 plus 1, which is negative 8. And so my answer is negative 8. Now, very quickly, we can look at A. A gets me 3x squared minus 11. If I plugged in 1 into that function, well, I would get negative 8 as well. Now for part D, we have two options again. If I found g of f of x, I can plug in 1 into that function and get my result. Or it's actually a pretty easy process to go that two-step route of, okay, finding f of 1. I plug in 1 into f of x. 3 times 1 plus 1 is 4, not too bad. And then I take 4 and plug it into g of x. Okay, 4 squared minus 4 is equal to 16 minus 4, which is 12. And so my answer is 12. And notice how I got to avoid the entire idea of foiling, which does cause a lot of errors historically. And instead I had to just do some very basic order of operations to get my numerical answer. All of that being said, if you plugged in 1 into part B, you should get the same result that I just wrote. Now, very similar logic to finding the domain when we had algebra functions. Finding the domain when we have composite functions is you find your composite function first. So I have f of g of x. Okay, well, f of x is x minus square root of x minus 4. I plug in g of x, which is 3x plus 1, into that function. I simplify, I get 3x minus 3. And then this is case 2. I have a square root. So I set that square root greater than or equal to 0. Good, I'm glad I worked it out in this problem. And then I'm going to go ahead and solve for x. So x is greater than or equal to 1. And so my domain is going to be, well, 1 and 2 infinity with a bracket on the 1 because it's greater than or equal to. Now, decomposing functions seem like a terrifying concept the very first time you see it. It's kind of hard to reason, okay, I need to find a function that would be a composite of functions. I have to find f, and I have to find g of x, that if I take g of x and plug it into f of x, I'll get h of x. Oh boy. Well, the truth of the matter is there's a lot of answers, and the other sad truth is that there's a lot of very wrong answers. In fact, there's probably more wrong answers depending on how you look at it. But instead of getting bogged down with all of these possibilities, there is a very simple way to kind of view at least one option of an f of x and a g of x, that if you compose the function, you get this result. And that trick or that tip or whatever is that you kind of look at the big picture and you look at the small picture. And so big picture, what's happening with h of x is that there's a bunch of stuff in parentheses, and that stuff is being taken to the 7th power. And so that's my big function. That's my f of x function, is going to just be x to the 7th. And now we think about small picture. Okay, well, now I talked big picture. What was happening is the big thing was getting taken to the 7th power. Well, what's happening in the small scope? What is being taken to the 7th power? F of x, f times x minus 3. That's my g. If we want to check it, take g of x, plug it into f of x, lo and behold, we get that result above. And sure, there could potentially be, if someone was writing diabolical math problems, that this trick didn't work, that you couldn't kind of view what's happening overall and then what's happening inside that thing. But the truth of the matter is, for this course, if you're able to view that, oh, you're taking something to the 7th power, or you're taking like the 5th root of something, and then looking at the inside of it, you're going to get this problem right. Now, let's say that we don't have a nice function. We're not given an algebraic x squared plus 3 or something like that. All we're given is values. Well, we can still find a composition of functions. We can find g of f of 1, and we do that in a two-step process. So I find f of 1 first, looking at my table. Okay, I have my x as -1, 0, 1, 2. So f of 1 is going to be the value when x is equal to 1. So go to my table. Oh, when x is equal to 1, f of x is equal to 2. And so my f of 1 becomes 2. And now I'm on to the second step of my project. I find what g of 2 is. Okay, well, coming to my table, I go to when x is equal to 2. That's the very bottom row of my table. And I look at what the g of x value is in this case. Well, it's -1. So g of 2 is -1, and in fact, overall, g of f of 1 is -1. And so that's kind of the theme of compositive functions, is that we go through a two-step process if we have numbers typically. We go through a two-step process. We find the inside value first, and then we take that inside value and plug it into the overall function. To kind of see that again, now I have two graphs. I don't have really functions, so I can't plug in values. I don't actually have values like in a table or something, but I actually do have values. I have to just do a little bit of work to find it. So with these two functions, I'm trying to evaluate f of g of 1. So I'm going to start with that inside, g of 1. What's g of 1? Okay, I look at my left graph. I go to where my x is 1, and then I trace up to my graph and see what the y value is. Oh, it's 3. So g of 1 is equal to 3. And now I go to my f graph and I plug in 3. So I come to my x value of 3. I trace up to my graph. f of 3 is equal to 6. So f of g of 1 is equal to 6. This is definitely one worth watching maybe 2 or 3 times because it seems weird and it seems very confusing. But once you break it down step by step, all I did was find the value of my g function when x is equal to 1, it was 3. And then I found the value of my f of x function when it was equal to 3, traced it up, my value was equal to 6. So same thing with the table, same thing when we were plugging in equations. Go step by step instead of getting overwhelmed and trying to do multiple steps at once for this section.